Hello everyone, welcome to the session of Bank History in Hong Kong. I'm Aidan, the first speaker and the moderator for live chat session later today. Before I start, I want to say thank you for joining this session. It is my pleasure to participate in the 2023 International Bank History Association Conference. During the presentation, please feel free to type the questions in the chat box. Once we finish all the presentations, we will come back and discuss those questions. So allow me to share my screen. So let's begin today's section by introducing our new program named Science, Environment, and Society. This is our first official attempt at local secondary schools, and we aim to introduce Bank History framework to Hong Kong STEAM education. We hope that one day the framework and content of science, environment, and society can be integrated into official liberal studies as STEAM curriculum. Here is a brief background about what we have been sharing in the past years, starting from 2016, when I was an MPhil student. It was the first time that we shared our teaching experience in a conference occasion. And the memorable Professor Cynthia Brown was the chair of my session, which made all this remarkable. And then we present in 2018 IBHA conference at beautiful Vanderbilt University. And in 2019 symposium, which was in collaboration with the SETI, Search for Extraterrestrial Intelligence in Italy. In the same year, we were very honored to have the invitation to attend the Japanese symposium in Tokyo. And lastly, we participate in 2021, the first online IBHA conference organized by Symbiosis School for Liberal Arts. So what we have been sharing is about our teaching experience in our undergraduate course, from a narrower focus on climate change discussion to transform into a macroscopic sustainability course. By incorporating Bank History framework, we enable students to have a new perspective to look at climate change and other environmental issues. Through equipping with this new lens, students have a stronger perceived instrumentality, which they believe more in themselves as agents for change and better prepare for future opportunities and changes in the 21st century. Especially, the changes are ever faster than before and keep accelerating. And not just for environmental perspective, but in a broader sustainability perspective, including the discussion of artificial intelligence. This is our existing approach at undergraduate course, at undergraduate level, and it is still going on. Our new approach is not going to replace what we have been doing at university, but we are aiming to introduce to local secondary schools. We renamed the program as Science, Environment, and Society to better deliver our message, and it is easier for schools to understand and incorporate under STEAM. One of the very crucial purpose of this program is to use a storytelling method that we try not to use complex wordings and try not to drill into complicated details. We try to advocate curiosity-driven approach, which we emphasize that students can ask any questions, although for some questions we do not have a good answer. It is no harm to ask. We also emphasize that we can use scientific approach to look at things around us, and knowledge and curiosity should not have disciplinary boundaries. We are not only encouraging students to ask questions, but we also try to demonstrate to teachers on how we should guide students to look for new knowledge. The structure of science, environment, and society is divided into 3 parts for 3 levels of students. Each module is taking up about 10 to 12 content hours. But of course, if the school wants to combine 2 groups of students in 1 batch, we are totally fine with it. We are flexible for school's own preference and requirement. For science part, we aim to deliver to secondary 1 students. This part mainly is about the physical environment around us. We focus on so-called big questions and origin questions. So we will cover from the Big Bang by firstly looking at world origin stories to physical environment in early Earth. In this part, we try to introduce what a scientific narrative should look like and what is evidence-based approach. For the second module, environment, we discuss the biological environment around us and mainly asking questions about life and environment. We cover from life definition to thresholds of life, looking at evolution and concepts of adaptation and extinction, and use some current environmental issues for our discussion. For the final module, we discuss social system around us and ask questions related to people, technology, and future, covering from hunter-gatherer society to agrarian society, discussing cognitive revolution, industrial revolution, scientific revolution, and to technological acceleration. As you can see, that this is a typical physics lab in Hong Kong secondary school. And you may notice that I was doing auxiliary teaching duties and checking around, not standing in front of the students. It is because one of our key features in this program is that we trained our undergraduate students to be the student teachers. These students have gone through our university level big history course, which is the same course I have mentioned earlier. They have decided the teaching materials and do the teaching demonstration in schools. Usually we had at least 2 student teachers for 1 session. And in order to maximize the teaching experience, we took shift to do the teaching demonstration. We all love the online platform, the Big History Project and its materials, but English materials and videos may be difficult for majority of students. So we have modified and translated the teaching materials, made it easier to cater for junior secondary students. We also have done voiceover for some videos as supplementary materials for the student. Since they are junior secondary students, we need to take care of their attention span. Therefore, we have enhanced the interaction by having as many a small activity as we can to teach complicated concepts instead of just talking. The left picture is an activity to help explaining the Big Bang by using milk, food dye, and detergent. The right one is about an expanding universe, Hubble observation by using balloon and marker. So in the left-hand side for this one, we also had a game on planet matching. There were statements about different planets and students need to match it. Top right is about explaining the balance of force that students need to enter into the paper circle without breaking it. The final one is about explaining Earth structure by using a boiled egg. Before we talk about the forthcoming plan, we are happy that one of our student teachers, Elaine, is going to share about her feeling to the new program. So Elaine, please.
Hello everyone, this is Elaine. I'm glad to share it today. So I joined a sustainability teaching course organized by Alexis with 6 other students this year. This course lasts for 2 semesters. For the first semester, our work is mostly about deciding the internal learning outcome of the courses. And then we make teaching material such as PowerPoint slides, worksheets, and we prepare equipment needed for different experiments. In the second semesters, we spent some time finalizing teaching materials, and then we went into 2 secondary schools to teach. So during the process of teaching, we made immediate changes to the teaching content after receiving feedback from the students and teachers. For example, one class with higher form students preferred to include more theories, and the other class with mainly Form 1 students, they prefer to include more experiments. So then we immediately adjust our teaching styles and the contents in order to match with their needs. At the end of this whole course, I think the comments we received are pretty positive and supportive. And I can see that there are generally more schools interested in the course we offered. Looking back into the whole journey, I think I would definitely recommend this course to students or to people for several reasons. First is the high flexibility given throughout the course, different from normal courses where they usually have a fixed set of curriculum and students sitting down to listen. This course gives us huge flexibility in deciding things we need to do. For example, we set our own schedule in finishing the assignments, in which the assignments are also set by ourselves, but not the teacher. Another reason why I would highly recommend this course is because of the opportunity to develop crucial skills such as self-motivation, time management, and self-discipline. So with all this freedom to create our own schedules and set our own assignments, we were able to take ownership of our learning process and become more responsible for our own success. This level of independence is not always present in other traditional classroom settings, but it is a valuable experience that prepares students for the workforce. Furthermore, taking this course also provided me with a unique opportunity to gain teaching experience. As the only course in the universities that allows students to teach, I was very lucky and I was able to develop valuable skills and gain practical experience in a real teaching environment. So throughout this whole journey and experience, I was able to learn how to effectively communicate complex concepts and ideas to others, how to manage a classroom, and how to design and deliver engaging lessons. For example, our lessons about big history are broadly categorized into 2 parts, the physical Earth and the biological Earth. Contents related to the physical Earth start from the Big Bang to the different stages of the Earth. So these topics usually include some complicated and professional terms that's too difficult for secondary school students to understand, and we were also afraid of losing their interest and attention during the classes. Therefore, we go through several rounds of modification to include only the most important and significant activities in that specific topic and engage students with different experiments to help them better understand the topics. So these skills are not only important for people pursuing a career in education, but also highly transferable to a wider range of other professionals. Of course, despite from valuable experience gained through this course, there were also some challenges that we had to overcome. One of the biggest challenges we faced was deciding what should we teach in order to make students able to understand the concept of sustainability and why is it important to us. We have to carefully select the topics and activities that would best engage our students and help them to develop a deeper understandings of sustainability and of the issues at hand. We also had to ensure that the course content was relevant and applicable to the students' lives and experiences, as this is we think this is a key to foster a sense of ownership and responsibility for sustainable practices. This requires us to adapt our teaching methods and materials to suit the diverse needs and learning styles of our students, which was a time-consuming but necessary task. So, but overall speaking, I think this course is definitely meaningful and beneficial to both the students and to the students we taught and us. And I would definitely recommend people to join this course. Thank you.
Thank you, Elaine. We understand that other student teachers may share similar feeling as well. Let me summarize and conclude today's presentation by discussing the challenges that future plans. One of the challenges we identified is the scope. The Science, Environment, and Society framework aims to cover from origin stories to modern society and to future. For the cohort in this spring, we have delivered the science part only. The whole interdisciplinary framework is appealing to principals and students because it is very fresh for them to listen such a scientific story, and the narrative is interesting and it can rejuvenate local STEAM development. However, teachers are not comfortable about the interdisciplinary framework. By training, they are specialists in 1 to 2 subjects. So teachers have not enough confidence to handle the materials. Second challenge is the stereotyping of STEAM education in Hong Kong. Most of the teachers believe STEAM has to be hands-on. However, our approach is more a storytelling approach, which may create expectation discrepancy. In light of that, our forthcoming plan is to keep modifying the existing materials and producing new ones. We need to explore the teaching demonstration to students and especially to teachers. We hope to extend our partnership with more schools and develop course handbooks for students and ready-to-teach package for teachers. So thank you for your attention. Up next, we have Dr. Rachel Oser to share her endeavor at her secondary school. Rachel is a science teacher at the Independent Schools Foundation Academy. While she has taught middle years program science since 2012, she is a member of the multidisciplinary studies team at her school and helps managing educational research. So Rachel, please.
Hello, and thank you for joining our session. Today I'd like to focus on big history in middle school. My name is Rachel Oser, and I teach at the ISF Academy, which is an international school in Hong Kong. Just to give you a little bit of context, the school is a private school, and their vision is independent, Chinese, and global. It is a pre-K through 12 international school with around 2,000 students. And as the emphasis is in Chinese, 70% of the instruction in primary school is in Chinese, and 30% of the instruction in secondary school is in Chinese. The curriculum is borrowed from the next generation science standards for primary, and for secondary, it uses the IB. I happen to teach in a department called Shuyuan, which is really more about enrichment and scholarship, and our areas of focus are in Chinese and Western classics, as well as STEM and other multidisciplinary areas. And we offer many courses that are electives or after-school sessions or summer programs. So this particular course, the Big History, I teach as what's called a HKUST, which is a sort of passion-based course for middle schoolers. And actually, the class that I teach is more for grade 7 and 8, so about 12 to 13-year-olds. And all students at the school have time off timetable, Wednesday afternoons. It's a really nice chunk of time, actually. So there's a 70-minute block before lunch and then a 70-minute block after lunch. And because of that, because lunch is in between, it also really allows us to go out if we need for field trips. And so when I talk about how many classes, it's the 2 blocks every Wednesday. So this is the description of the course that students were then able to choose from. There were actually many courses. And you can see here that it's adapted. It uses the Big History project as a framework, but it is more of a science-based course. So as you can see, we have an experimental inquiry-based focus, and we also include field trips and all of this in our understanding of the universe. So here is just a breakdown of which topics we do, which thresholds, and how many classes we spend on it. When I say classes, also these are the 70-minute classes. So this comes out in total to about 29 classes. And that was 1 semester worth. This was the first year that I had to reduce the course from a year long to a semester, so I did have to cut out some parts. But now reflecting on that, it probably does work better for younger students who have less of the attention span. So we usually start out with a general introduction to science. With this question of what is a scientist, I usually ask the students the first thing to draw in their notebooks their vision of a scientist. And many will draw, the sort of Albert Einstein look, a male with glasses, curly hair, a lab coat. And then after they draw that, I'll ask them a little checklist. Who included, this, and that, or beakers or bubbling bottles. And the idea of that is really to deconstruct the image of the scientist so that everybody understands that really anyone can be a scientist. It's really just about inquiring. And throughout the course, we generate wonder questions. So I start that on the first day because this is all about thinking big and wondering about the universe. I also ask them to write up a history of their own lives. And this is really interesting for 12 to 13-year-olds because that is developmentally, they're really very focused on themselves. So when they write a history of their own lives, typically they begin with perhaps when they were born or when they were babies, where they go to school, etc. So afterwards, of course, I ask them a checklist. Who included their parents? Okay, most often they will. Who included their grandparents? Who included, and I'll go all the way back. And of course, going back into, which planet do they live on, the universe that they live in. And then I think the penny often drops that there's just a lot more to history than their own 12 or 13 years. Of course, we introduce David Christian's History of the Universe and the thresholds, and we spend some time on modeling and learning about scale of the universe. as well as origin stories, which is always a fun way of exploring. We usually do origin stories through a jigsaw exercise. And then we go through the classes. Typically, it was 2 classes, so 1 threshold per Wednesday afternoon class for thresholds 1 and 2. And then there just is a lot more detail once we move into planet Earth and life, as well as including field trips, which is why we have some more classes here. In terms of the Big Bang, I often find students in Threshold 1, students are fascinated by that because they typically don't learn this in any other class. So they'll often have a lot of questions. And we also talk about the amount of space within an atom. And the reason why I have a yoga link here is just because we do this little yoga meditation exercise, which visualizes how much space there is inside your body. So the crux of that is always, let me move forward for a minute. This is actually the yoga class, but the conclusion of that is if you were to suck all the air out of your body and you were just left with the matter or the stuff that you're made of, it would come down to the size of a sugar cube. So we will often have them reflect on that by giving them a sugar cube. We also do some science experiments, endothermic and exothermic, to show, how energy is either taken in or released. And we talk about, of course, the famous equation E equals mc squared. And even though these are 12 to 13-year-olds, they do often get it just in terms of the big picture. Usually these students will start from the periodic table in their science lessons. So being able to start from the Big Bang and where elements come from is usually quite eye-opening to them. We also do nuclear fusion and a couple of activities in terms of how they measured the life of a star in terms of measuring distance using parallax. We also have an observatory with telescopes. Of course, we're only able to go during the day, so usually we'll view solar activity, but that's always a fun field trip. And then moving into Threshold 4, we talk a lot about the rock cycle. We do some modeling. We do another science experiment showing them how, I'll usually have them, our theme is a sugar cube, but melt down a sugar cube to show the different phases of the rock cycle. So first they'll crush it in terms of forming the sediments and how that forms sedimentary rock. And then they will boil it and have it harden so they can see how that forms metamorphic rock. We also, at this point, the last 2 years, I've asked Professor Alexis Lau from HKUST to give us a lecture about the early atmosphere, and students are often surprised in learning that the early atmosphere looked very different than the way it does today. We also have scheduled a visit to the Hong Kong University Geology Museum. They have an exquisite rock collection, as well as just a great history of Earth. And then we move into Threshold 5, life. And here is where we'll use some simulations in terms of understanding how important evolution is for the development of life on Earth. And we also explore biodiversity through various activities. Also in the Geology Museum, they'll have a lot of fossils in terms of early life. We had a guest speaker from WWF, and we also did the activity iNaturalist, where students use an app to document all species around them. And it will help to identify the name of the species. So you can see here that it'll often give you suggestions. It's a form of social media, in fact. And sorry, I forgot to mention this, but we do use analogies a lot. This particular analogy is going back to really the beginning, really threshold 1, when we talk about free energy and energy available for orderly order, right? The energy that is invested in in forming order and reactions. So students understand that although there was a lot of energy, especially coming out of the Big Bang, not all of it was available for use. And David Christian has this nice analogy in his book Origin about a drunken policeman, which is sort of the energy that is wasted, if you want to say, right, or the explosive energy versus the policeman who's directing traffic, and that it represents the energy that directs all the other reactions that lead to the evolution of the universe, of the planetary system, and eventually of life. So going back, we also have a nice seashell collection, so we'll use that sometimes also to try to identify those and understand how they interact with life. We do some water testing. Moving on to threshold 6, this is also something I find that students don't really talk about in their classes. Usually it's not included much in their science classes, and then it's often too early for their humanities classes. Just learning about different hominids and the evolution of humans and early humans, and how we learn a lot of that history from cave drawings. So we have a few projects around that. Moving into threshold 7, agriculture and civilizations. We do some soil experiments and some gardening on our rooftop as well. And then, sorry, just a moment. Threshold 8, we move into the modern revolution, and here we'll usually include, we talk a lot about the Anthropocene, and how that has actually led to human-based climate change. And so we visit a place called Zero Carbon Park, which has a lot, as it sounds, they aim, or I believe they meet this goal of producing zero emissions. So you can see the solar panels on top of the roof here, and they have a lot of, and this is actually quite a feat in Hong Kong, where the weather often requires air conditioning. But they show us all these underground systems and how they use wasted heat from some of their generation systems for, to power some energy generation, as well as they have these high volume fans and other techniques to shuffle the warm air out and keep the cool air in. And so it's a venue and sort of a display center for all of these different strategies for lowering our energy consumption. It is part of the Construction Industry Council, so they also have different displays on materials and how those are sustainable, so you can see the students visiting those here. We also, moving into, I'll go back to, this slide. We do from the Big History resources, there's a really nice activity on comparing civilizations, and we actually have a little debate on, and they get to vote for their favorite civilization, and how those contributed to various cultures on Earth. And we then move into the future, the Internet of Things, and how we use data essentially to make informed decisions. And that's where this activity will come in, where we show students that instead of, let's say, back in threshold 7, there was a lot of trial and error with moving into the agricultural revolution and what works and what doesn't, and being dependent on the weather. Whereas today we can use sensors, and how the modern revolution has brought us into the era of making data-based decisions. So you can see here we have a soil moisture sensor and a light sensor, and then students get to program that. This is just a microbit, to then to lead to an automatic watering system. And they can see how that transforms agriculture and, of course, yields greater productivity, which is very much necessary for our growing human population on Earth. And here we have a summary of the 8 thresholds, and the students have kept track of all the keywords from each threshold, as well as a summary page that they have in their notebooks. I really use notebooks a lot for the students, mostly because they otherwise use screens too much. And we have a few handouts for each threshold, and I really encourage them to use the notebook. So we have one side, which is a blank page, and that's more for free drawing, concept maps, and their own interpretation. And then the other side is lined paper, and that's where they're writing down information, either from the board or from research. And hopefully, if they have kept their notebooks neatly, as I say afterwards, it's their own publication, right? They've personalized it, and it gives them a whole history of the universe. Actually, first I'm just going to, unfortunately, the students were not able to join live. The timing doesn't quite work out for this conference, but 2 students before the last day of school did volunteer to give a little testimonial. So I'll play those videos now.
Hi everyone, I just took the big history course, and I think that everyone should take this course, because when I first learned this course, the information, especially from the first and second threshold, I thought were key parts to finding out more about elements and all that. Because we learned what elements are and how they work, but we don't really learn how they come and where they came from. So I think that's a very important part of science, and that's why I think everyone should take this course.
Sorry, I hope that was clear enough, but what I really loved about what he said was, he says, we often learn about the elements, but not where they come from. And this was actually a student who maybe by the 3rd class or so, he raised his hand and he says, why don't we ever learn this in other classes? And for me, that really brought home the value of what big history does in terms of expanding students' minds and really getting them to think outside the box. Here's another testimonial.
Hi, my name is Josh. I also took the Big History Project, and I agree with Duncan. I feel like, yes, this is something that everyone should learn, because all these thresholds can teach us lots, and can definitely help us with the understanding of human history, as well as helping us with the understanding of sciences. Like the first, second, and third threshold can really help you understand how the universe formed, and can really help you in your AP Physics course when you go to university. And 4, 5, 6, 7 can help in your history course, because like a general summation of the entire history of the universe. And I think this is really helpful for the education of people overall.
Again, I hope you were able to hear what he shared, but he talked about how what he learned in this class can be really helpful for his future science and history classes. Oops, sorry. And here's what I'd like to do in the future, perhaps next year, moving forward. I would like to add another element to this course, which is the open school approach. And you can see that there's a website here called Make It Open, and it's a collaboration, an international collaboration between many different schools and other informal learning institutions around the world. You can check out their website, and they have at the moment 16 different learning scenarios. But the idea of open schooling is to build collaborations between what we're learning in the classroom and the wider community. So whether that means we go out into the community and educate, or whether we're bringing in experts from the community into our classrooms to help educate. It's really about bridging those worlds, so students understand that learning is not just in the classroom, as well as the community being able to benefit from the educational institution. So, for example, one of their learning scenarios is a physics class, and how they go to a playground, a local playground, and each of the students takes one of the rides in the playground and does some research on the physics principles behind how it works. And they create a little video and a QR code and some keywords on the physics principles, and they put this little poster. They created a permanent poster that they then put up next to that ride in the playground. And then they had an open day where they invited the community to come and try out all the parts of the playground and talk about the physics behind it. So that's one example. I haven't decided exactly what I'll do yet, but and as you can see in some of the lessons that I've already described, we do have some field trips and we do bring in some experts. But I would like to work on a project that brings big history to our community. Perhaps it's some kind of display in the community, and it's an open day, because I really do feel that this is an approach that changes the way people think and the way people view the world. Thank you so much for listening, and please feel free to email with any questions or concerns. And I apologize that I can't be there in person, but I hope that my colleagues can help to answer your questions.